Right, okay. A'udhu billahi minash shaitanir rajim. Bismillahir rahmanir rahim. And assalamu alaikum wa rahmatullahi wa barakatuh. And hi everyone. Right, okay. Good morning, good evening, good night. So today in this video we are going to discuss grade 10 unit number 3, that is structure of the matter. So before moving to the lesson, I want to introduce myself. I am Fazil Kareem from Infinite Science Academy. Right, we'll start the class. Right, okay. Grade 10 unit number 3, the first chemistry lesson that is in your syllabus. Right, grade 10 unit number 3, that will be the first chemistry part that we are going to learn here. Right, okay. So before moving to the lesson, you want to understand the heading, that is matter. Right. So what do you mean by matter? What does it mean? What does it mean? Matter means, okay. So from your grade 8 itself, you are studying what do you mean by matter, right? The things which have mass and which occupy space is called as matter. In the exam, they will never ask what do you mean by matter in the exam. Okay, don't worry. Okay. For just introduction, we won't explain that one. No, that's why I'm explaining here. In the exam, they will never ask what is matter. Okay. For example, just I have pen or the pencil or the eraser, all those things that you're using in your day-to-day life, they are matter, right? So these matter are made up of atom. That thing also you know from grade 9. I think you may have studied those parts. Okay. So the next question, how the matter is made up of? You know, they are made up of atom. For example, just see this book here. This book is made up of papers, and these wall, they are made up. This wall is made up of bricks, right? So if I ask a question below, how the paper is made up of and how the brick is made up of, or you said that the book is made up of paper, fine, okay. The paper is made up of atom. Now look at this picture. Look at this picture. Here you can see a picture here, right? So here you can see the pencil is made up of atoms. You can see the atoms here, right? The carbon, the black color one, that is made up of carbon, right? So it is made up of carbon atoms. You can see the atoms here, right? And look at this diagram here. The brick. What did I said that? The brick is made up of atoms. The wall is made up of bricks, and the brick is made up of atoms. Look at this diagram. The water, ice cube, is made up of molecules or the atoms. So I hope that may have got the idea what is atom and how the matter atoms are arranged and how the matter is formed. Okay. Now, how the atoms will be in shape. In previous pictures, I showed you that the atoms are in spherical shape, right? So the first idea was explained by John Dalton, that you may have studied in grade 9. Okay, John Dalton said that the atoms are in golf ball shape, spherical shape. You know the golf ball, spherical shape structure, right? Okay, same like that. Atoms also will be as golf ball model or golf ball shape, explained or said by John Dalton. Okay, and then after John Dalton, scientists invented that inside the atom there are some small particles. Where inside the atoms, inside the atom there are some particles, small particles. They are named as subatomic particles. Who invented these things? Later, after John Dalton, the scientists invented that inside the atom there are some other small particles, and they are named as subatomic particles. They are protons, neutrons, and electrons. Now you may have a doubt, right? Okay, inside the atom we have the proton, we have the neutrons, we have the electron. Okay, fine. And how do they have been arranged? Where the proton is situated, and where the neutron is located, and where the electron is located? You may have a doubt like that, right? Earlier said that atom is spherical shape. Okay, fine. And inside the atom, now you know we have proton, electron, neutron. Okay. And where these electrons, protons, neutrons are located? You may have a doubt like that, right? Okay. We will discuss that. So here, how these subatomic particles are arranged. You may have a doubt. We have the protons, we have the electrons, we have the neutrons. Okay. So first idea was given by J. Thomson. He introduced the plums pudding model. What is it? Plums pudding model? What does it mean? Okay. Look at this picture here. You can see the plums and the puddings in the picture, right? Normally, when you are making the pudding, we will add some plums, right? Will we add the plums in an order? No, right? Randomly, we will be adding the plums. Am I right or wrong? When you're adding the plums for the pudding, will you put that at the top and the bottom and the left and the right? No, right? Randomly, you will put the plum. Same like that. J. Thomson said that inside the atom, we have the protons and the electrons randomly spread. throughout that. This model was explained by J.J. Thomson. This model is called as plums pudding model. Inside the pudding, the plums are there. Same like that here, we have the atom and we have the electrons. Same like the plums and the pudding. Pudding and the plums. Here we have added the plums to the pudding. Same like that, we have added the electrons to the atom. This model was explained by J.J. Thomson. Then later, a scientist named Ernest Rutherford explained no, that model is wrong. The J.J. Thomson model is wrong. He explained a new model, the accurate model. Who introduced this one? Ernest Rutherford. This model is called as planetary model or the nuclear model. We'll explain. We'll discuss what is a planetary model, what is a nuclear model. We'll explain we'll discuss one by one. Right? Here, sorry. There's a mistake. Sorry. Okay. He is one scientist, Ernest Rutherford. Okay. He said that below, at the center, there's an area named nucleus. Just look at this picture below. Just look at this picture here. The center part, that is called as nucleus. We can explain by using this picture, right? Okay, here, the center, that is named as nucleus. Just look at the diagram here. At the center, there's a very small area called nucleus at the center, and already I said that inside the atom we have the protons, we have the neutrons, we have the electrons, we have 3 subatomic particles, right? So at the nucleus, we have the protons and the neutrons. Just look at the idea, just look at the picture here. We have the nucleus. Inside the nucleus, we will have the neutrons and we will have the protons. Who said this, Kulal? Who said this? Ernest Rutherford mentioned this one. But you may remember, in previous model, in the plums pudding model, J.J. Thomson didn't explain regarding the neutrons, right? He explained only regarding the protons and the electrons. But Ernest Rutherford, he introduced the neutrons. The neutrons. Just look at the picture here. At the nucleus, we have the protons and we have the neutrons. So there's a small area called the nucleus. Inside the nucleus, you have the protons and the neutrons. You can read the notes that I have been put in the screen, but there's no need to read those notes, okay? Because I already explained. If you have a doubt, you can pause the video, you can stop the video, and you can read the notes, okay? Now we are going to discuss. Okay? You can understand the same idea by using another picture. Just look at the picture here. At the same time, we have the nucleus, the center part, a small area, and inside the nucleus, we'll have the neutrons and the protons. Okay. Now the third thing that he said, that he compared the size of the atom and the size of the nucleus by using an example. For example, just say, you're going to keep a small chickpea. You know what is chickpea, right? Chickpea means in Tamil you will say kadale, konda kadale. Okay. So when you're keeping a small chickpea at the ground, at the center of the ground, can you see that, Bulla? Even when you're keeping a football itself, we can't see the football, right? Because the football ground is very, very big. Same like that, he said that, Bulal, the atom, he compared the size of the atom with the ground and size of the nucleus with the chickpea. So actually size of the nucleus is very, very small. For example, just say atom like a ground and nucleus as a chickpea. Can you imagine that? How much small will be the nucleus? But actually in the diagram, I have drawn as much as big I can, because I want to explain you. If I want to explain, I want to make the nucleus big. But actually, the size of the nucleus will be very, very small. When we compare in the ground and the chickpea, you can compare the idea, right? The ground and the chickpea same like the atom and the nucleus. So atom has a ground, nucleus has a chickpea. So a chickpea is very, very small when you're comparing to the ground. Same like that. Nucleus is very, very small when you're comparing to the atom. Already atom is small, okay. We are comparing the size, okay. So actually the atom, the size of the nucleus will be very, very small. But for the pictures, in the diagrams, I will be using very big images to explain that. Okay, Nane. So fourth one, he said that the electrons are rotating around the nucleus. Just look at the picture here. At the center, we have the nucleus. Ah, okay, fine. Okay, fine. And inside the nucleus, we have the neutrons and the protons. Okay, fine. Inside the nucleus, we have the protons and we have the neutrons. Okay, done. Around the nucleus, just look at the picture here. Around the nucleus, the electrons are rotating. Am I right or wrong? The electrons are rotating. Just look at the picture here. Electrons are rotating here. Electrons are rotating around the nucleus. Is it clear, below? And below, he said that he compared this system as to the solar system. Can you compare the solar system and the atom? Just look at the picture here. He has compared the solar system with the atomic model. The model that he introduced, the nuclear model. Oh, the name is called as planetary model. Because he compared the atom, the nucleus, protons, electrons with the solar system. Just compare the picture here below. At the center we have the sun. Here at the center we have the nucleus. Around the nucleus, the electrons are rotating here, same like that. Here the planets are rotating around the sun. Am I right or no? Just compare the picture. Just look at the picture here, below. Just look at the picture here. What's happening? Just look at the picture. What is happening? Did you get the idea? Okay. So just compare the picture here, below. We have the nucleus at the center, and here center we have the sun. Around the nucleus, the electrons are rotating around the nucleus. Same like that here around the sun, the planets are rotating around the sun. Same like that here, he compared both of these things. Okay. So this model is called as planetary model or the nuclear model. Okay. And the sixth one. Okay. So sixth one he explained that is. Now you want to be very careful. Okay. You want to be very careful, right? Just look at the screen. Okay. Now I'm going to put a circle here, right? So what is the name that I have given here? That is nucleus. Am I right or no? The center part that I have made around here, that is nucleus. So if I ask you, what is the charge of the nucleus? What will be the answer? If I ask, what is the charge of the nucleus? You want to be very clear, you want to be very clear in this one, plural. If I ask what is the charge of the proton, that will be positive charge. The red color one, that is positive charge, protons. And the white color one, that is neutrons, that is no charge. They don't have any charges. They don't have any kind of charges. The electrons, they will have negative charge. Okay, fine. My question is this, plural. If I ask what is the charge of this one, the area that I have been shaded here, if I ask what is the charge of that part, what will be the answer? The nucleus will be positive charge because we have the protons. Proton is positive charge, right? The red color particles, they are positive charge, and there is no any charge from the neutrons now. So if I take only the nucleus, the charge of the nucleus will be positive charge because inside the nucleus where that I have been shaded here. So inside that area, we have only the protons with the charge. We have the neutrons. They don't have any charges now. So there is no need to worry. So here, the protons will have positive charge. Because of that proton, the nucleus, the center part that I have been shaded here, it will have the positive charge because of the proton. Am I right or no? Am I right or no? If you didn't get the idea, what do you want to do? You want to replay the video again, okay? Because I can't explain again. Because if I explain again, the video will be long, right? So you want to make it forward and you want to listen the video again, okay? It's okay, man. Don't move forward, okay? Just look at here. I'm going to explain again once again. Just look at the thing, okay? At the center, at the nucleus, we have the protons and the neutrons. Am I right or wrong? We have the protons and the neutrons. What is the charge of the proton, plural? Charge of the proton, that is positive charge, right? Positive plus charge. And there is no charge in the neutron, right? So if I remove only the nucleus in my hand, if I remove the nucleus from the screen and just imagine I have the nucleus in my hand, what will be the charge of my hand? Inside the nucleus we have only protons. There's no charge from the neutrons, right? So there's no need to care about that one. So in my hand, I will have only the nucleus, and inside the nucleus we have only the protons, so positive charge. Inside the nucleus we have the neutrons, the white color particles, no charges, so there's no need to worry. Okay, the seventh one, the final one, you want to be very careful in that one. Just look at the picture and you want to tell me the answer, right? What will be the charge of the total atom? Earlier we were discussing the charge of the nucleus, not the atom. Now I'm asking, what is the charge of the total atom? What is the charge of the total atom? So here, if you want to find the total charge of the atom, what do you want to do? Shall I tell one thing, interesting thing here? Number of protons is equal to number of electrons. How it is possible? Yes, that is a law. Okay, number of proton will be equal to number of electrons. Then just look at the picture here. How many protons are there in this picture? How many protons are there? 1, 2, and 3, and 4. We have 4 protons. And already I said that if I have 4 protons, I will have 4 electrons. So 1 and 2 and 3 and 4. And already you know one thing, already you know one thing, the proton will have what charge? Positive charge, the plus charge, right? And the electrons will have negative charge. So if I ask what is the total charge of the atom, you want to add the protons and the electrons. Totally we have 4 plus charges, 4 protons, and I have 4 minus charges, 4 electrons. So what will happen? Those plus 4 and minus 4, they will be balanced. So the total charge of the atom will be 0. Why it is 0? 4 protons means 4 electrons. So 4 proton, 4 electron got balanced. So total charge will be 0. Okay. Now just look at this picture. How many protons are there? How many red color balls are there? 3 protons, right? So 1 and 2 and 3. So totally we have 3 plus charges. And already I have explained, if you have 3 protons, if you have 3 plus charges, how many electrons will be there? 3, 1 and 2 and 3. So 3 plus and 3 minus got balanced. So totally 0. The charge will be 0, balanced. 3 plus 3 minus got balanced and total charge will become 0. Did you get the idea? If you didn't get there, don't worry, I will explain once again. Okay, just look at this picture. Just look at this picture. How many protons are there? We have 3 protons, 1 and 2 and 3. 3 plus charges, 3 protons positively charged. How many electrons are there? 3 electrons, 1 and 2 and 3. So 3 plus, that means 3 protons, and 3 electrons, 3 negative, 3 minus, 3 negative, got balanced. So charge will be 0. So here the Ernest Rutherford said that the number of electrons is equal to number of protons. So the atom will be neutral, electrically neutral. There will be no charge for the atom. If I ask what is the charge of the nucleus, what will be the answer? If I ask what is the charge of the nucleus, can you say neutral? No. Nucleus, inside the nucleus we have the protons. Here protons, and inside the nucleus we have the neutrons. So if I take only the nucleus, it will have positively charged. I have already explained the 6th one. This one I have already explained. If you take only the nucleus, it will be positively charged. And if you take total atom, it will be no charge. It doesn't have any charges because those plus and the minus will be good balanced. Okay, Dani? Right, okay. Now we are going to discuss the last one, the 8th one. Okay. If you want to understand this one, you want to know a small thing here, right? Okay. Just imagine that you are going to rotate this bowl, right? Okay, the metal bowl. You're going to rotate the metal bowl. What do you want to do? If you want to rotate this one, what will you do, Pula? What do you want to do? If you want to rotate this bowl, what do you want to do here? You want to pull, right? You want to pull, right? You want to pull the ball and you want to rotate like this. You want to apply a force towards you. You want to pull that one towards you. Am I right or wrong? Okay, fine. So I want to ask you one question. Okay, while you are rotating like this, you are pulling that metallic ball. Will that metallic ball will move towards you? No, right? Even you are pulling that one towards you, it will never move towards you. But you are pulling that one towards you. But still that is not moving. That is not coming towards your face because it is rotating. Am I right or no? Am I right or no? So now you want to compare the same scenario with the atom. You may ask, how can I compare this one and the atom? You may have a doubt like that. Just look at the picture here. Here we have the protons with the positive charge and the electrons, they are negatively charged. So what will happen? Plus and the minus, they will be attracted. They will be attracted each other. So what will happen? Even they are attracting each other, they will never contacted. They will never be for each other. That ball, as this ball is not coming towards your face. Am I right or no? You are rotating here and you are pulling the ball towards you. Still you are pulling that one. The ball will never come towards your face. Because why? Because you are rotating this one. Same like that, Pulahal. The electrons and the protons, the negative and the positive, the green color and the blue color. Between those things, we have attraction, but they will never fall each other. Because why? Because why? Because they are rotating. Same like this example in the while you are rotating that metallic bowl. Just look at the example. Just read the sentence here. Electrons are attracted towards a proton, but they do not fall because they are rotating very fast, like this. Did you get those 8 statements regarding the Ernest Rutherford model? Okay, we'll do a quick revision. Okay, regarding the Ernest Rutherford model. Before moving to the Bohr model, I want to explain those things. Okay, start one by one. Okay. First of all, the plum spreading model was introduced by J.J. Thomson. Within 1 minute, I want to explain. Within 2 minutes, I'm going to explain all the things. Okay, plum spreading model was introduced by J.J. Thomson, and he said that inside the pudding, we will have the plums randomly spread throughout the pudding. Right? Same like that here. Inside the atoms, the negative and the positive charge particles are randomly spread. Who said this thing? J.J. Thomson. But later, after J.J. Thomson, Ernest Rutherford introduced, no, that model is wrong. This is wrong, right? He introduced a new model. He said that at the center we have the nucleus, and inside the nucleus we will have the protons and we will have the neutrons, the red color and the blue color, the protons and the neutrons, and the electrons are rotating around the nucleus. Who said this singular? Ernest Rutherford. Okay, then after he stated 8 things. Okay, we'll discuss one by one. At the center, we will have the nucleus, and inside the nucleus, we will have the neutrons. They don't have any charges. Neutrons are neutral, and the protons are the green color one. They are positively charged. So Ernest Rutherford said that at the center we have the nucleus. Inside the nucleus, we will have the protons and we will have the neutrons. Okay. Then after, he compared the size of the atom and size of the nucleus. He compared, he said that atom as a ground and the nucleus as a chickpea. For example, just can you imagine, Pulal? Can you observe the chickpea at the ground when you're keeping a chickpea at the center? No, right? Same like that. Actually, size of the nucleus will be very small. Size of the nucleus will be very small. But to explain, I can't draw like that, right? So in the picture, the diagram will be big. Okay, fine. But this size of the nucleus will be very, very small when you're comparing the size of the atom. Okay. And the fourth thing, the electrons are rotating around the nucleus, and he compared this system with the solar system, and he said that this model is named as planetary model. He just look at the comparison here. Nucleus as the sun, electrons as the planet. And sixth one, the nucleus is positively charged. Why the nucleus is positively charged? Because just say that you have been taken only the nucleus, right? You have removed only the nucleus and you have taken in your hand. So what will be the charge inside the nucleus? Inside the nucleus you will have only the protons and the neutrons, and neutrons, they don't have any charges, right? The white color one, they don't have any charges, but the protons, they are positively charged. So charge of the nucleus will be positive. And the seventh one, the very important one, the charge of the total atom. If I ask what is the charge of the total atom, what will be the answer below? If I ask what is the charge of the total atom, what will be the answer? Total atom. Total atom means we want to consider the nucleus and also the electrons. Here, just look at the picture here. We have 3 protons, so 3 positive charge. And already I said that if we have 3 protons, we will have 3 electrons, so 3 minus charge. So automatically they will be good balanced. Okay. And the 8th one, why the electrons are not attracted towards the nucleus? Why? What is the reason? Why they do not fall each other? Why do they do not contact each other? What is the reason for that one? Even they are attracted, even they are oppositely charged, even they are plus and minus charges, even they are attracted, they will never contact each other because they are rotating very fast. You can compare that one with this example. If you want to rotate, you want to pull, but even you are pulling that ball, it will never move towards your face. Am I right or not? Never, it will never happen. Because why? You are rotating. If you stop rotating, then it will be falling towards your face. Same like that here, the electrons are rotating around the nucleus. In the exam, they will ask, the proton is positive charge, electron is negatively charged, even they have positively charged. Why do they do not contact each other? Because they rotate very fast. That will be the answer for this one. Okay. And the nail Bohr, we'll discuss regarding the Bohr model, Neil Bohr model.